So in this video, we're going to take a look at some simple data sets and look and see if we can compare them using averages and a measure of spread, which is the range. So let's just jump straight into it and have a look at our first example. So we've got two diagrams underneath, and they illustrate some data about two groups of children and their scores on a test. First of all, we've got to calculate the mode and the range. So let's start looking at group A. Well, the mode is the most common, and we can see this from the vertical line graph because it is the tallest one. So that one is 3 because 5 people had a score of 3. The range here, well, okay, that is going to be the biggest value take away the smallest value. So that will be 5 take away 1. So the range is 4. Now then, let's move on to the second group of students. So group B. Well, in this case, the mode is 3 still. And that's because that is the most common score to achieve. 4 people got a score of 3. The range, well, that is going to be the biggest number, 6, take away the smallest number, which was 0. 6 take away 0 is 6. Okay, so we've done the first part of our question. We found the mode and the range for each of these groups. Let's see what part B is. Describe the differences between the groups. Okay, so we can say that, first of all, the mode is not telling us much by comparison. Both of these two groups had the same mode score. They both had an average mode of 3. But the range tells us something because B has a lot larger range comparatively of 6 compared to 4. So that means that in group B, we have a wider spread of scores. The scores are more varied. So that is what the range is telling us. And that's true, isn't it? We can see that. We can also look at the diagrams themselves. We could say that in group A, we've got I would call it a normal distribution around a score of 3. It's very even and it's symmetrical. It's spread out in a symmetrical pattern. Whereas in group B, it's kind of symmetrical, I guess, but it's far more spread out. No one scored a 2, only one person scored a 4. So we can certainly say that the students in group B are more spread out in their scores. Let's look at another example. So Catherine plants 2 different types of tomato plants. She records the number of tomatoes that she picks from each plant every day for 10 days. Her records are shown below. Compare the 2 plants and recommend what type she should buy next year. Okay, so if I was going to find an average, I think I would use the mean in this case. So if I add up all of those tomatoes picked for plant A, I get 42. So to find the mean, I've got to do 42 divided by 10 because there's 10 days, and that comes out at 4.2. Now, the range here, well, the biggest number that I can see is a 7, and the smallest number is a 1. So 7 take away 1 is 6. Now, plant B, if I add those numbers that they look larger, they do in fact come to 71. So to work out that mean, I do 71 divided by 10, and that is 7.1. If I want to find the range for plant B, then I'm going to do the biggest number, which is 9, take away the smallest number, which is 5. So plant B has a range of 4. Okay, so let's compare now using that information. So first thing to say is clearly I'm getting more tomatoes from plant B. So plant B gives me more tomatoes because the average per day is a lot bigger, 7.1 compared to 4.2. Also, I can say that the amount that I'm getting off plant B is more consistent because it has a smaller range. It only varies with a gap of 4 compared to 6 for plant A. So not only is are the tomatoes in plant B being picked, there's more to be picked, I can also say they're consistent in the amount that gets picked comparatively to plant A. I would recommend that Catherine definitely buys more of plant B. Okay, I hope this helps. Now, just a few little notes on the averages, okay? I just want to quickly run through one last thing. When should we use the mean? When should we use the median? When should we use the mode, okay? Now, there's no definite answer here, but you can make some suggestions about when this might be useful. So let's talk about the mean first of all. Well, the mean is a great tool, certainly as long as we don't have too many outliers and we have quite a symmetrical, evenly distributed data. I'll tell you why. So if you think about it, imagine I've got a data set which was this: 3, 4, 2, 3, 7, 5, 1,023. Now, perhaps this is some sort of measurement, okay? Maybe it's the number, something's happened, right? Okay, I've got these numbers. Now, if I was to work out this average mean, this number, the 1,023, is going to mean that the mean average is a lot larger than it should be. And I think that this was actually a mistake. Perhaps there was an error in the data. Perhaps it shouldn't be there. And by considering the mean, it's going to really skew that average and mean that it's not where it should be. Because an average really is kind of working out, roughly what's that data being most of the time. So if we are not symmetrical, we have what's known as an outlier, then we are definitely not going to use the mean. But if it's symmetrical or it's all pretty consistent, then yeah, the mean's a great idea. Now, perhaps in that example, the median or the mode would be most important, right? And median, again, it's all about these outliers. If we think about something like salary, well, if I wanted the median salary to work out how competitive and how affluent my country was, the median would be much better. It wouldn't be skewed by, for example, the salary of the top 1% of people or the king of a particular country. So a median is a great idea if we have this data at the ends being very, very high, okay? Now, the mode is useful, but only when we're looking for the most common item. So, for example, if I was making shoes, adult shoes, it might be very useful for me to work out what shoe size was the most common. So, therefore, I would be using the mode if that is my desired interest. So it's really important when we are looking for the most common item. But otherwise, it is not used that much, really, when we're dealing with large amounts of data.